Hello everyone! Welcome back to Science Online class. Today we're going to talk about static electricity, part 1. You can find this in your physics book, page 305. Are you wondering what static electricity is? Let's check this out. From the video, you can see that Jared rubbed a straw on the floor, right? And then what happened to the straw? Yes, the straw can attract some papers. And then he charged a straw, a balloon, a comb, a fork, and a bat, a plastic bat. What does that mean? I have a simulation that can show you how the charges can move from one object to another. Okay, everyone, I insert this link in your Google Classroom so later you may check this out. But for now, I will show you how I use the simulation. Here is the simulation. I have a cloth and a balloon. All around the cloth, there are plus, minus, plus, minus, plus, minus. Inside the balloon, there are also plus, minus, plus, minus. What are they? Now, let me put the balloon to the cloth. See what happened? Now, all the minus jumps to the balloon. What happened next? Now, when I put the balloon close to the wall, what happened in here? Look, the negative in the wall is pushed away from the balloon. What happened? Yeah, this is because of the nature of charges. So what are charges? Let's go back to the PowerPoint presentation to get to know charges. As you can see in the simulation before, you can see the symbol minus, and plus, plus. What are they? Yeah, they are the part of atom. Do you remember atoms in grade 8? Let us recall what atom is. Look at this. The minus all around here are the electrons. They are the negative charge of the atom. The positive one in here, they are protons. Protons are the positive charge of the atom. And then protons and this one, what is this? Yeah, this is neutron, the neutral charge of the atom. They are packed together in the nucleus, the core of the atom. Now, what are electric charges? Look at this, everyone. An atom has an equal number of electrons and protons, like what you have learned in grade 8. It is electrically balanced. That's why the atom becomes neutral. An atom becomes charged when the number of electrons and protons is not equal. This occurs when electrons are removed from or added to the atom. If electrons are removed, the atom becomes positively charged. If electrons are added, the atom becomes negatively charged. Okay, so if an atom has more electrons, it becomes negatively charged. If an atom has less electron than the proton, it becomes positively charged. An atom that is charged is called an ion. To understand how the neutral atom becomes charged atom, take a look at this. If electrons equal protons, it is neutral atom. If electrons is greater than the protons or gaining electrons, the atom is negatively charged or it becomes negative charge. If electrons is less than the protons, or losing electrons, it becomes positively charged or becomes positive charge. Now, how do positive and negative charges interact? Do you remember what you have seen in the simulation? The negative one pushes away the negative in the wall, right? Now, look at this. Can you see two charged rods? In this case, glass rods, okay? The hanging rod and then the free rod. The hanging rod has the positive charges in it, while the free rod has the positive charges as well. When they are brought near each other, the glass rods repel each other. What about the second example in here? The free rod is negatively charged. The hanging rod is negatively charged as well. What happened? Yeah, they repel each other. What about positive and negative charged rod? In here, you can see the hanging rod is positively charged. The free rod is negatively charged. When they are brought near each other, the positive rod attracts the negative rod. So we can conclude like charges repel and like charges attract. Let's move to another topic, measuring electric charge. You can see this in your textbook, page 307. Electric charge is measured in coulombs, or C. One electron has a charge of 1.6 times 10 to the power of minus 9 coulombs. Therefore, 1 coulomb of charge is made up of 1 coulomb divided by 1.6 times 10 to the power of minus 19 coulombs per electron equals 6.25 times 10 to the power of 18 electrons. Can you get this? To understand this, suppose that I have a question for you. The first question, what is the SI unit of electric charge? Yeah, the answer is coulomb. Another question, what is the amount of charge carried by an electron? What is the amount of charge carried by an electron? Yeah, it is 1.6 times 10 to the power of minus 19 coulombs. If the question is, how many electrons needed to carry 1 coulomb of charge? How many electrons needed to carry 1 coulomb of charge? Yeah, you can divide 1 coulomb per 1.6 times 10 to the power of minus 19 coulombs equals 6.25 times 10 to the power of 18 electrons. So, you will need 6.25 times 10 to the power of 18 electrons. Electrical insulators and conductors. Materials can be classified as electrical insulators or electrical conductors according to their properties. Now look at table 16.1, comparison between electrical insulators and conductors. Based on the motion of charged particles, in electrical insulators, charged particles are not free to move about. What does that mean by charged particle? In this case, the charged particle is electron. Now, in electrical conductors, the charged particles are free to move about. What does that mean by charged particle? Yeah, electron, yeah? Next, about the ability to conduct electricity. The ability to conduct electricity in the insulator is low, while the ability of conductor to conduct electricity is high. Now the method of charging. To charge the insulator, you can use the method friction. To charge the conductor, you can use the method induction. Can you mention another example of insulators and conductors? Let's get close to the meaning of insulators and conductors. Insulators, materials that do not allow electrons to flow through them easily. Insulators can be easily charged by friction, as the extra electrons gained cannot easily escape. While conductors, materials that allow electrons to flow through them easily. Conductors cannot be easily charged by friction, as the extra electrons gained can easily escape. Rubbing materials does not create electric charges. It just transfers electrons from one material to the other. But don't get me wrong, everyone. In the insulator, the movement of the charged particles are on the surface only, not inside the object, only on the surface. To understand this, you may check the simulation again. Let me show you another example of rubbing. After being rubbed, a plastic ruler can attract paper scraps. Can you see that? The things that you didn't see is when the ruler is rubbed with another object. Ruler carries electric charge. It exerts electric force on a paper. This charging method is called charging by friction. The interaction between static electric charge is called electrostatics. In here, the method charging by friction holds true for insulator only. Take a look at another example. When a balloon rubs a piece of wool, look at this. Electrons are pulled from the wall to the balloon. The balloon has more electrons than usual. Now, the balloon is negatively charged, while the wall is positively charged, since it loses some electrons. Now, let's take a look at the charges acquired when the materials are rubbed together. Of course, in this case, they are common materials. Look at this glass rod. When it is rubbed with silk, look at the direction of the electron transfer. Electrons move from the glass rod to the silk. Now, the silk has more electrons than usual, so the silk becomes negatively charged. While glass rod, it loses some electrons, so it becomes positively charged. Example question. A polyethylene rod is rubbed with wool, and a glass rod is rubbed with soap. When the two rods are brought close together, what is observed and why? First, you need to check the pairs of materials and the charges they acquire when rubbed together in the previous slide. So, when you rub polyethylene rod with wool, the polyethylene rod becomes negatively charged because the electrons from the wool move to the polyethylene rod. Now, when you rub glass rod with silk, the glass rod becomes positively charged because the glass rod loses some electrons. Now, when two rods are brought close together, the rods attract each other because unlike charges attract. That's all for Static Electricity Part 1. I'll see you on the next meeting. Bye-bye everyone.